Right, right. Y is equal to 0 plus half gt square. So from that we can write y is equal to half gt square. Let us take it as the equation 2. From equation 1, this one, x is equal to ut. Let us take equation 1, x is equal to ut. From that, t is equal to x by t is equal to x by u. X by u. Therefore, y is equal to half g, t square is nothing but x square by u square. X square by u square. From that, y is equal to half g by u square. That means g by 2u square we can write g by 2u square into x square. Y equal to g by 2u square into x square. Here g is the constant, u is the constant, v is the constant. All are being constants. That's why it can be written as y is equal to, let us take k x square. Let us take k is the another constant. These are all constants. Let us take k. So here k is equal to g by 2u square. K is equal to g by 2u square. Now this equation, this equation represents this equation. This equation represents the equation of a parabola. The equation of a parabola. Equation of a parabola. Equation of a parabola. మనకి parabola equation వచ్చింది అంటే this is the path equation. This is the path equation of the horizontal projectile. Y is equal to kx square in terms of y component and x component, that means coordinates. Path equation of the horizontal projectile, but it is in the form of parabola equation. That's why we conclude that one thing. The path of projectile, the path of horizontal projectile, is parabola. Okay, right. This part. So path of horizontal projectile is parabola. Path of this type of projectiles is parabola. Okay, this is the parabola equation in case of horizontal projectile. Right, this is the path equation in case of a horizontal projectile. Okay, right. Take a notes. Just write down once, check it and all, then you can pass చేసుకోండి, then write. Okay, note down in your notebook. When you are note down, then you can just pause your video and you can. Okay, right, ma? Right, last thing కనిపిస్తుందా? Okay, right. This equation represents the equation of a parabola. The path of horizontal projectile is, therefore path of the horizontal projectile is parabola. Okay, right. Next. Right, next. Okay, next. Velocity of a projectile. Simply I can write velocity of a projectile at any time. Velocity at any time. Okay, velocity at any time. Simply velocity after time t. Let us take this equation, this diagram. Okay, velocity at any time. Okay, that means simply velocity after time t. Okay, velocity after time t. What is the projectile velocity? Okay, right. Now same conditions. Let us take suppose a body is projected with initial velocity u horizontally. Okay, horizontally from a height h. After some time, let us take the body is at a point P of x comma y, horizontal direction, vertical direction, body is at this place. Now we have to find the first of all horizontal component of velocity, then horizontal vertical component of velocity. By using those two velocities, we can find the resultant velocity. Okay, right. After that, velocity. Okay, right now come to the point. First one along horizontal. Along the horizontal, we get the horizontal component. Along the horizontal. So we know that ux is equal to 0, ax is equal to, sorry, ux is equal to u, horizontal component of velocity, ux is equal to u. This is the ux, horizontal component of velocity. Ux is equal to u, ax is equal to 0, and after some time let us take, so t is equal to t. Okay, right? T is equal to t, and let us take after some time velocity at any time, final velocity Vx is equal to question mark. Vx is equal to question mark. Okay, right. So from this we can write, we need to find the horizontal component of velocity. So Vx is equal to ux plus ax into t. V is equal to u plus at formula. V is equal to u plus at kinematic equation formula. Now one thing, why we are using these formulas only because of V equal to u plus at, s is equal to ut plus of at square. Okay, v square minus u square equal to s. All these equations are valid in case of uniform accelerated motion. So here uniform accelerated motion only because of g is acting entire journey. Here and here, whatever it may be, g is common. G is acting vertically downward only. So it is the uniform accelerated motion. That's why we have to use this one only. So Vx is equal to x plus ax into t. Now Vx is equal to ux, u only, plus ax, 0 into something time. So Vx is equal to u. No, you understood one thing. Vx is equal to u at any time. No. Vx is equal to u at any time means initial velocity, horizontal component of initial velocity u at this place. Horizontal component of initial velocity at this place u only. Horizontal component of velocity at this place also u only. Horizontal component of velocity at this place also u only. And here also u only. Means throughout journey, horizontal component of velocity is fixed. Then oblique projectile throughout journey u cos theta is fixed. But here u is the horizontal component. That's why u is fixed entire journey from here to here, projection point to striking point. Horizontal component of velocity is fixed, constant. Okay, but in case of horizontal projectile, horizontal component of velocity is u. Clear? Right now, come to the point. It is the proof. At any time, horizontal component of velocity is u. Clear? Right. Next, along vertical direction. That means along vertical motion. No. U y is equal to 0 because of there is no vertical component of initial velocity, and a y is equal to g because of acceleration due to gravity, vertical direction g is acting, plus g. Okay, right. Time t, after time t anukuntunnam kabatti, then vy is equal to question mark. By using these four, right now, by using these four we can write vy is equal to uy plus ay into t. Right now, vy is equal to vertical component of velocity at any time t equal to uy means 0 plus ay means g into t. That means vy is equal to gt. ఒక అద్భుతమైన విషయం తెలిసింది ఇప్పుడు మీకు ఏంటంటే vertical component of velocity top to bottom it can be increasing in t times with respect to time t. Vertical component of velocity is increasing because of 1 second, 10 meter per second, 2 seconds, 20 meter per second, g value let us take 10, 3 seconds, 30 meter per second. Understood? So vertical component of velocity top to bottom increasing, clear, in the horizontal projectile, right now. So along the horizontal there is a component of velocity, along vertical there is a component of velocity. After time we got, now we can find the velocity. Okay, velocity after time, after some time or after any time, after time t. Velocity after time t is v bar is equal to vx I cap plus vy j cap, clear. V bar is equal to vx I cap plus vy j cap. V bar equal to vx I cap plus vy j cap. From that we can write v bar is equal to, right now vx means u I cap plus vy means gt j cap. Okay, v bar is equal to u I cap plus gt j cap. No, this is the velocity at any time. Velocity at any time. For example, after 1 second, we can substitute after 2 seconds, after 3 seconds, after 4 seconds, like that. So velocity at any time for a horizontal projectile, clear, right? So magnitude of velocity, next magnitude. Okay, magnitude is nothing but modulus v bar is equal to square root of, already you know that, vx square plus vy square. So modulus v bar is equal to square root of vx square means this one will u square, otherwise here u square plus g square t square, clear, u square plus g square t square. Okay, u square plus g square t square. This is the magnitude of the velocity after time t, or at any time t, right? Now next, direction of velocity. Because of velocity is the vector, we can find the magnitude and direction. Direction of velocity. Let us take, there is a angle theta. We makes angle theta with the horizontal direction. Okay, with the horizontal direction. So here we can draw like this. Okay, let us take tan theta is equal to opposite by adjacent. Then from this figure here, tan theta is equal to opposite by adjacent, and opposite means vy component, adjacent means vx component, vy by vx, clear, vy by vx. Vy means what, how much, vy means this component gt, am I right? So here tan theta is equal to gt by u. From that we can write theta is equal to tan inverse gt by u. This angle with horizontal, not with vertical. This is the angle, theta is the angle made by velocity with horizontal. So with horizontal, don't get confused here, with horizontal, clear, with the horizontal. Okay, right. So this is about velocity, clear, this is about velocity, direction of velocity and magnitude of velocity, horizontal component of velocity, vertical component of velocity. Okay, right? Check it and note down. After that you have to practice. Okay, right? We note చేసుకునేటప్పుడు చక్కగా పాస్ చేసుకొని, నాట్ పాస్. ఓకే, రైట్. నెక్స్ట్ one more thing is, right, next there is the two motion parameters. One is the time of descent and the range. So now we can find the time of descent. Time of descent, clear, time of descent. Then already you know the time of descent means the time taken by the body or projected body. Okay, the time taken by the body which is projected horizontally, which is which is projected horizontally, okay, which is projected horizontally with initial velocity u, whatever it will be, time taken by the body which is projected horizontally when it reach the ground, when it reach the ground or striking point, when it reach the ground or striking point, ground is called, okay, the time taken by the body after when it reach the ground or after it reach the ground is called time of descent. Time taken by the body which is projected horizontally from a height, horizontally from a height when it reach the ground is called time of descent. Okay, time of descent. It is denoted by TD. Okay, TD. Right. So along vertical direction, let us take the values. Along vertical direction. Okay, along vertical direction means along vertical motion. Let us take the values. Vertical motion anna uy is equal to 0, ay is equal to plus g, okay, and ay is equal to plus g, and after that we have to take the y, no need to, we have to find the time t is equal to td when it reach the ground, time t equal to td when it reach the ground, and after that what we have to take height s, sy is equal to, let us take h, total height it can travel vertical displacement, sy is equal to h. So from these four equations we can write sy is equal to uy into t plus half a by t square. Clear? Sy is equal to uy into t plus half a by t square. Then sy means h, vertical displacement, this much of height. Uy means 0 into t plus half ay means j, t square, td square. Okay, right. Now h is equal to half g td square. From that we can write td square is equal to 2h by g. From that td is equal to root of 2h by g. And this is the time of descent formula. In this case time of descent is nothing but time of flight only. So time of descent to time of flight, total journey time total, that is only. That's why time of descent is equal to root of 2h by g. Clear? Root of th by g. One thing you can observe that time of descent doesn't depend upon the u. Clear? Time of descent lo ekkada manaki u ledu. Ante time of descent u మీద డిపెండ్ అవ్వడం లేదు. నువ్వు ఎంత స్పీడ్తో ఎంత వెలాసిటీతో త్రో చేసినా సరే, దట్ డిపెండ్స్ ఆన్ ఓన్లీ హైట్ ఓన్లీ. అండర్స్టాండ్? డిపెండ్స్ ఆన్ ఓన్లీ హైట్ ఓన్లీ. మీకు గుర్తుందా ఫ్రీలీ ఫాలింగ్ బాడీ కేసులో కూడా టైమ్ ఆఫ్ డిసెంట్ ఈజ్ ఈక్వల్ టు రూట్ 2h by g ఓన్లీ. డజంట్ డిపెండ్ అపాన్ ద ఇనిషియల్ వెలాసిటీ, projected velocity. Clear? Right? So we can write that one more point. Time of descent. Okay, just we have to write that time of descent. Time of descent is equal to root of 2h by g. Root of 2h by g. Note. What is the note point here? Time of descent. Time of descent does not depend on. Time of descent does not depends on initial velocity. Clear? Time of descent does not depends on initial velocity u. It depends only on height of the tower. Height h depends only on height h of the tower. Or whatever it may be the point. Okay, so time of descent is equal to root 2h by g. Time of descent means time taken by the body from the projection point to striking point. Clear? Or otherwise when it reaches the ground, what is the time taken means time taken is equal to 2h by g. Here, and one more point is here, time of d is nothing but time of flight only. Time of descent is nothing but time of flight only in this case. Clear? This is about time of descent or time of flight. Okay, right. Take it, Nana, note down.